You have to keep these things separate when you look at the output. This refers to the magnitude, in this case, because it's correlation, it's the magnitude of the relationship between the two variables that you tested. And we decided that was strong positive, didn't we? This is completely different. This refers to this SIG or P number, which is right here, 0.018. That refers to the probability that the result that you got with the data you collected, the correlation you got, would occur by chance alone. Remember anything coming back to you now? So, what this number is saying is, how likely would this correlation occur just if we use random numbers, if it was just a random calculation using random numbers? If this number is low, that means the correlation would not happen very often by chance, therefore something systematic and real produced it, therefore we can count on it. Remember that? Yeah. So a low number here is actually a good result, because the lower it is, the less likely it would occur by chance, and the more likely something real or systematic produced the correlation. So the way I like to express this is to invoke my very poor imitation of not the current President Bush, but the previous President Bush, Bush Sr., and try to help you remember this. When it comes to magnitude, especially for correlation, high numbers, good, good. Low numbers, close to zero, bad, bad. In the probability part of the result, low numbers, close to zero, good, good, because you have statistical significance and it wouldn't occur by chance, something real produced it. High numbers, bad, because a high number here says chance would produce this so often you can't count on it. Randomness will produce this, you can't count on this result. Whatever it is, it doesn't matter, strong or weak. If you don't have significance, you can't count on it. It could occur by chance too often, don't count on it. So, this number, 0.018, it turns out, is statistically significant because it's less than the cutoff level we accept in the social sciences. Any number for probability for a statistic that is less than 0.05 is considered to be statistically significant, assuming you set your level of rejection, let's call it, at that level. And we'll get into that more in statistics. I won't worry you about the difference between probability less than 0.1 and 0.05 right now. If it's less than 0.05, that means you have statistical significance. Is 0.018 less than 0.05? Good! So we've got statistical significance, which tells us that this is a reliable, real result. We can count on this relationship between gender and IQ. We can count on this because it's statistically significant. If the number is 0.05 or less, we're okay. And it turns out that for correlation, SPSS is extremely friendly because it actually puts this little asterisk here. And it says, hello, it's less than 0.05, it's significant. And you know it's significant because it's told you that. The third thing it has is the end. We don't need to really worry about that. But these two things you do need to look at, and you need to train yourself to try to sort of ignore whenever the SPSS package correlates a variable with itself. It correlated gender with itself and got a perfect correlation, no surprise there, right? And it correlated IQ with itself and got a perfect correlation, no surprise there. But what's interesting is it doesn't matter whether you correlate using gender first entered and then IQ, or IQ first and then gender, you get the same correlation. And that illustrates that correlation cannot demonstrate causation. It doesn't matter in the bivariate case which order you use when you enter your correlation. You're going to get the same correlation between any two variables. And we all remember from statistics, I hope, the reason for that is that correlation is based on the cross products of z-scores. So it doesn't matter which order they're entered in. You're going to get the same bivariate correlation. Whichever variable you enter first makes no difference in two-variable correlation. So that's how to read this exciting output. And in this particular case, but not in all tests, SPSS is so very friendly. It says correlation is significant at the 0.05 level, two-tailed. It's helping you. in some of the tests you might want to run, it won't be so friendly, but here it actually gave you some help on how to interpret this. But notice that your challenge when you write this up is, even if you get this far, it will not do to say, for example, in your report, the correlation between gender and IQ was statistically significant. Moving on to the next research question, you're going to have to include an English language, plain English explanation of what the meaning of that correlation was. In this case, because we coded the variables such that on gender, 1 was male and 2 was female, that meant those that were higher on gender tended to have higher IQ scores, and we know that because it's a strong positive correlation. We also know it's significant because the probability level was 0.018, which I'm having trouble writing because this marker has it in for me. But anyway, let's see if I can fix that 0.018. So that, in sum, is how you would handle this situation and how you would run this simple correlation in SPSS and how you would interpret the results. I hope you're getting the notion that it's very easy in SPSS to enter data. As long as you keep track of your variables, one per column, and you understand how you measure them. That's the easy part. Then selecting the test is not very difficult, because most of the time, most of the tests you will select will come from the Analyze menu, which is the drop-down menu at the top of the screen. That's the next step. Having selected the bivariate correlation test in this case, all we did was check out our options, click OK, and get a nice box for our results. The hard part, if there was a hard part, was then looking at the not very friendly results that SPSS produces and interpreting each part of what it means. And that's where a book like this is helpful if I'm not around or someone else isn't around like me, because for each chapter in this book, it covers a specific statistical test, and it will help you decide what part of the output you need to look at. It's not very good looking at in-depth questions like the one that you asked, the difference between Pearson R and Spearman Rowe, for example. You won't find very good answers in books like these, but this will tell you which statistical, when you look at output, what to look for and what to avoid. So, that's in sum what we did. That's how SPSS works. And when you practice by doing the exercise yourself, the first credit, you'll get the same result when you do this exercise in the Quick Start Guide to SPSS in here. And once you've mastered that, you will be on your way, and you can choose any statistic you want, nearly, from the Analyze menu, and you'll be on your own.